Hello, algebra students. We are back. This is Mr. Montes, and we have another lesson for you all for Algebra 2. If you did notice, my face is actually in the corner here of the screen. I decided to try out my new string cam. It's kind of weird to listen to a disembodied voice on these videos, so I figured, hey, add my face to it. Maybe it'll change things up. So we're just going to try it out. If it works, it works. If not, then it doesn't, and I'll never do it again, right? But at least now you know that I'm alive and well, and I'm good to go. All right, so let's jump into this. Last week we talked about multiplying binomials. This week, well, actually, that was the last 2 weeks. Last week, not last week, on Monday, we talked about using the area model. So what we're going to do here is I'm going to go over an example using the area model again for two binomials, and then we're going to jump into what it looks like for a trinomial times a binomial, and then we're going to multiply two trinomial expressions together using this area model. All right, it's actually the same thing. It's not very much different. It's pretty much the same thing. It's just the box that we draw is going to look a little bit different due to the number of terms that we have. So let's jump into this. We got 2x minus 7, and we got x plus 4. And if we're going to multiply using the area model, we're going to have to draw a square, and there's going to be 1, 2, 3, 4 compartments in that square. The square doesn't have to be perfect. And what we're going to do is we're going to put down the first term here, 2x, and then we're going to put our next term down here is negative 7. Remember, if this is a minus, we got to keep that attached to that second term. On the left-hand side, we have x, and that's for this factor, and then we have positive 4. Right, so now what I'm going to do is I'm going to go ahead and find the area of each square, and then I'm going to add them all together to find the resulting product, right? So I got 2x times x, that's this upper left-hand corner. So that'd be 2x to the power of 2, or 2x squared. I got 2x times 4, which in this case would be 2 times 4 is 8x, right? Then I'm going to go back to the top right-hand corner. Negative 7 times x is negative 7x, easy peasy. And then negative 7 times 4 is that last little box. That'll give us negative 28. So now what I'm going to do is to find, I've multiplied all those pieces out. So I'm going to find, if I'm going to find the product, I just got to add all these pieces together to find the sum. And these two right here are like terms on the diagonal, right? And we're actually going to talk about that a little bit later when we come across trinomials, because this actually works out pretty nicely when we organize ourselves. So we have 2x squared. That's this one, check, we have that one. Then we have these two middle ones. I'm going to write them both out. So positive 8x minus 7x. So check, check. And then negative 28 minus 28. So let me simplify some stuff. We got some like terms, like I said, that piece and that piece. And then, so 8x minus 7x is going to give us positive 1x, but I can just write that as x. And then I'm going to have minus 28, and at this point, I am done. So, as you can see, the area model kind of facilitates the multiplication of these two factors, whereas we used to have to distribute the first factor to each piece and the second factor, each term. In this case, it's kind of all taken care of using this new little area model method, right? So let's jump into what it might look like for a trinomial. Let me go back here, find my example. Good. So what if instead of a binomial times a binomial, we had, let's say, 2x minus 5, and we multiply that by 3x squared minus 4x plus 2. Let's say we were multiplying that out. Okay, so what I'm going to do is I'm going to make my box again, but I have to be cognizant, I have to be aware of what it is that I'm multiplying together. And I don't know if you can hear that, that's my son upstairs, so just ignore the baby crying. So back to this. So we have a couple of things going on. We have two pieces here, and then have 1, 2, 3 pieces here. So instead of a 2 by 2 box, I'm actually going to have a 2 by 3 box, or a 3 by 2. It really doesn't matter how I write it out, but I like to go, let's go long ways. Let's go, whoops, let's go this way. Let's go this way. And I'm going to split it down the middle. So that's 2. So this will take care of my 2x minus 5. So that'll be 2x and negative 5. And then I need 3 columns because I have 3 terms in this piece right here, right? So I'm going to go ahead and split this up into 3. Let's see if I can do it. Let's see if I can do it evenly. 1, 2. All right. Not so even, but I'm not an artist and you probably aren't either, so don't worry about that. So now let's write out 3x squared minus 4x and then positive 2, right? Again, I kept track of my negative, right? The negative's right there. So I kept it here, as well as the minus 5 here. I kept track of that here, right? So now what we're going to do is find the area of each box and then add those all together to find the product of these two polynomials. So let's get started. Top left-hand corner, let's keep ourselves organized. 3 times 2 is 6. And when I multiply x squared times x, I actually end up with x to the power of 3, x cubed, right? So next piece, let's go all the way across the top first, and then we'll come back and we'll do the bottom. So I got negative 4x times 2x, that's negative 8x to the power of 2. And then I got 2 times 2x, and that's going to be 4x. All right, so let's go back to the bottom row, and we're going to multiply. First, find this the area of this bottom left-hand corner. 3x squared times negative 5x. Negative 5 is negative 15x squared. Next one is negative 4x times negative 5. That's positive 20x. I guess I don't need the plus, right? And then the last one is 2 times negative 5. Easy, negative 10. And I just want to point out something. This doesn't always happen, but when we're organized and structured in a what we call a oh shoot, I forgot the word. The word is in descending degree, meaning I got my x squared term here, then my x term here, x to the power 1, and then no x. I got my x term here and then no x. So it's in descending order of degree. We actually get some nice stuff happening. We get this diagonal right here and here. Those are going to be like terms. We can tell because this has a power of 2 for the x. This has a power of 2 for x, and this has a power of 2 for x as well. Also, this one right here and this one right here, the power of x is 1 for each piece, so they are also like terms. So we're going to keep that in consideration when we start writing this out. So let's do that. We got 6x cubed. That's my top left-hand corner. I'm going to write out minus 8x squared, and instead of going across the top, I'm going to go ahead and take its like term, negative 15x squared, and I'm going to put that right there. Right? Now let's do the next one. It's positive 4x. And then I got its like term, which is positive 20x. And then I got the last piece, which is minus 10. Now, what you're going to discover is that as you do these problems, you're actually going to get, you might start doing some of this simple addition of like terms in your head, and that's okay. You don't have to show that step every single time. But for now, it's nice because you guys are learning this model. So we have 6x cubed. We got negative 8x squared minus 15x squared. So let's see, that's negative 23x squared. Sometimes I add things wrong, so if I do, just fix it. Plus 24x. And the last one is minus 10, and we are done. So that's what a trinomial times a binomial looks like. So now we're going to jump into a trinomial by a trinomial, and you may have already figured out if a binomial times a trinomial is 2 by 3, then a trinomial times a trinomial is going to be 3 by 3. So we're just upping the number of small squares within that area model, right? Let me scroll down. Let's do the last example, and then we're done. Let's go. Oops, I have it right here. Give me 2 seconds. All right, so I got 2x squared minus x minus 2, and we're going to multiply that by 3x squared plus x plus 3. All right, so let's set this up. Let's make this big because we need a lot of space. I need to split this down this way and then 2 this way. It doesn't matter if it gets a little messy, that's okay. But I do need space and I didn't give myself any. So let's move that up a little bit. It's the benefit of having a Microsoft Surface. Except when everything goes crazy, right? All right. So 2x squared minus x minus 2. 2x squared minus x minus 2. All the way across the top. Down the bottom, I'm going to have 3x squared, positive x, and then positive 3. I don't have to include the plus there, but if it helps you out, just go ahead and do that. So let's start. 2x squared times 3x squared, that's 6, because that's 3 times 2. And this will be x to the power of 4. X squared times x squared, you add those exponents together. Negative x times 3x squared is going to be negative 3x to the power of 3. I have x squared times x is going to be x to the power of 3. And then negative 2 times 3x squared is negative 6x squared. All right. Let's go to this middle row. 2x squared times x is 2x cubed. Negative x times x is negative x squared. And then negative 2 times x, negative 2x. Right? Last row, first column, 2x squared times 3, 6x squared. Negative x times 3, negative 3x. Negative 2 times 3 is negative 6. Okay, so I'm going to come through, and just like before, on the diagonal, we have like terms. But again, that only happens because we have this descending order of degree for each term. So it's organized nicely, and we aren't missing any terms. If that were the case, if this were 2x squared minus 2, this wouldn't be organized as nicely. But when it's like this, it kind of lines up for us. I got like terms here and here, right? They all have the power of 3. I also got like terms here, here, and here. They all have x to the power of 2. And then I actually have one more. What color should I use? Blue. Negative x, negative 2x, and negative 3x all have a power of 1, right? The variable, right? So let's organize ourselves. And what I'm going to do is I'm going to actually skip writing the whole thing out, right? So I'm just going to write 6x to the power of 4. That's the top left-hand corner. And then I'm going to take care of, so I took care of that one. Let's take care of 2x cubed and negative 3x cubed. So 2x cubed minus 3x cubed would be negative x cubed. And I know you can hear my son because I can hear him. Ignore him. He gets a little hungry and grumpy sometimes. So 6x squared. And I have a negative 6x squared, so those would cancel out and leave me with 0, but then I'm just left with negative x squared in the middle, so that's minus x squared. And then the light blue, negative 3x minus 2x is minus 5x. And then the last piece is negative 6. So I end up with that thing right there. So let me check my work. 6x to the 4th minus x cubed minus x squared minus 5x minus 6. There are so many minuses in there. It's awesome. So we are done with this piece. Remember, if you have questions or concerns, go ahead and email your teacher, and we will get back to you as soon as possible with some help. Don't forget to submit those assignments. Again, if you didn't know, we sent out the rubric letting you know what it takes to get an A, what it takes to get a B, C, D, and an incomplete if that's what you're going to choose to take. For an incomplete, you really need to contact your teacher first, and then they'll get together with your counselor and your administrator and figure something out. But in any case, that's it for today. Hope you guys have a great week. Talk to you soon.